students, welcome to the chemistry sessions once again. So we will be dealing with the JEE advanced pattern for the biomolecules. So it's very important, it gets repeated frequently in JEE advanced. So you need to pay attention in these very questions. So let us just start off with the question number 1. What do we have? The structure of D plus glucose is given over here, right here. And you need to find out the structure of L minus glucose. So remember, we have discussed a similar kind of a question in mains as well. But there it was asked about the L plus glucose, not the L minus. Here you need to pay attention on what kind of configurations are given in the question. So they have given D plus and you need to find out the L minus. That means at one kind of a isomer, what was that? There was clockwise rotation of the plane polarized light, and I need to find out the one having the opposite rotation for the plane polarized light. And how do we do that? We do that by making or creating a mirror image of the same. So that would be our answer. So let us just create the mirror image for this. You need not go into the options, just try to find out the answer first for this one. So you need to have a proper mirror image. So it would be like this. That is how you are going to make it. Everybody knows how to make the mirror image. It's very simple. OHH, OHH. That is how you are going to make it. And I need to now put one more here. So this is first of all L. How does it implies the configuration L? It is due to the presence of this OH to the left hand side, and also this is what? This is the enantiomer of the given kind of a compound. That means enantiomer is always rotating the plane polarized light in the opposite direction. So earlier it was positive. So here now the sign would be L minus. So that is what we need to look for the options. So let us just see the options here. What do we have? Okay. So if I look on to the first let us just check out the answer. Answer has got one OH towards right, that is the second OH. So we'll remember that. Let me just rub this off in order to make you see all the kind of options properly. So what options do we have here? OH towards the right. That is the only option that we are getting, and you can compare the others as well. There is no such kind of an option that we have obtained. So this very is the answer. I hope everybody has got it. You just need to look carefully on the question what they are actually asking, whether it's plus or minus. So just be very careful. Now let's move on to the next question. What does the next question say? So it is cellulose upon acetylation with excess acetic anhydride. So I need to acetylate via acetic anhydride. I need to choose this reagent for acetylation. Gives cellulose triacetate whose structure is. So first I need to know what is the structure for cellulose. Then I will acetate it or acetylate it. So in acetylation what is there? Always OH is replaced by OAC. That is what? That is COCH3. So that is what we need here. OAC we need here in the replacement of each and every OH. So we all know what cellulose is. Cellulose is actually beta D glucose which are connected via C1 and C4 linkages. So we have got cellulose, 2 beta D glucose I have got. That is how the connections are made in cellulose. Plus again beta D glucose. One is connected via C1 and the other is connected via C4. So first we need to look for that structure. So let us just have option number 1. If you see, there is what? Yes, there is beta glycosidic linkage. So as you can see over here, C1 is connected via C4. So this is a C1, this is C4, C1, C4, again C1, C4, C1, C4. So that is how the connections is made. Now if I look on to the next options, what do I have? If you see over here, there is no C1 and C4 connection. If you look very properly, there is only C1 and C1. C1 connected with C1, C1 with C1. So that is how in both the options the connections are made. So you need not go for these two options, these are incorrect. Let's just now see the options, the initial options what we had. C1 connected via C4. Now, you need to just check whether the OH, all the OH are replaced by OAC or not. That is what the acetylation is. Also, they have used excess of acetic anhydride. That means each and every OH must have been replaced by OAC. So that is what our purpose here for this excess of acetic anhydride. I hope everybody is getting the reaction. So I need to choose maximum OAC, the structure having maximum OAC. Here you can see most of the OH have remained unreacted, and over here you can see all the OH are replaced by what? Replaced by OAC groups. I hope that is clearly visible. So that means this very is the correct option. I hope everybody has followed up. So A is the correct option over here. Let's move on to the next question. So what do we have next? Now it's the time for multiple choice. That means I've got more than one options as right answer. So let us just read out the question. For invert sugar, now we are dealing with inversion of sugar. Invert sugar, the correct statements is or are. What are the given things over here in the question? Given are specific rotations of, first of all, they are given sucrose, maltose, glucose and fructose in the aqueous solution are. So they have given all the values of the specific rotation. Now let's just check up the options. Invert sugar is prepared by the acid catalyzed hydrolysis. Yes, it is prepared by acid catalyzed. Of maltose, is this option correct? Here, if you check or recall the concept of inversion sugar, that is only dealt in the case of sucrose. So always remember that inversion of sugar, whenever I am dealing with inversion of sugar, so what do we call here sugar as the sucrose. So here we take up D-sucrose and what do we get? We get glucose, D-glucose and D-fructose. That is what we get, and the total specific rotation that was initially taken, that is plus, and the total specific rotation for the mixture that we get after the conversion, after the acid hydrolysis is via HCl. So what happens? The sign of the specific rotation gets changed, it gets opposite, that means it gets inverted. Earlier it was plus and the overall mixture has minus as the specific angle of rotation. That means this is known as inversion of sugar. I hope everybody has recalled the concept now. So this makes first statement as incorrect because it is not maltose but sucrose. Now, invert sugar is an equimolar mixture of D plus glucose and D minus fructose. That is very true. This is true. Now, specific rotation of invert sugar is minus 20. So I need to find out the specific rotation for this very particular question and we have given the values. What are the values? Earlier it was minus 66 and now what we have got? For L minus, so just be very careful while reading out the question. L minus glucose is having minus 52, that means plus glucose will be having plus, and L plus fructose they have been given 92. That means again I need to rotate it or change its sign. So what will it be? It will be definitely minus sign, because here 92 will be converted to minus 92 degrees and minus 52 degrees get converted into 52 plus. So earlier there were given the specific rotations for L configuration. Now we have got specific rotations for D configuration. That is what we obtain here in the case of actual inversion of sugar. So I need to actually take these values and then find the specific rotation, angle of specific rotation. So what will it be? So let us just find out the specific rotation for the entire mixture. It would be 0.5 and 0.5. That means I am taking as a whole 1 mole, 0.5 for this, 0.5 for that. So it would be 0.5 into 92 minus 92 plus 0.5 into 52. So that is what we need here, and I can take 0.5 common. What do we get? We get minus 40, and now what do I need to do? I need to multiply by half. This is nothing but 0.5 is nothing but half. So what do we get here? Minus 20 degrees. So that is what the question also says. That means this very option is also correct. So just be very careful, you do not need to take the value for maltose or sucrose, but glucose and fructose. So these values you need to consider. So I hope everybody has got the answer right. On reaction with Br2 water, invert sugar forms saccharic acid as one of the products. So if you know, if you have the idea of this very reaction, Br2 water, bromine water is always a mild oxidizing agent. So here Br2 water is always a mild oxidizing agent. That means it converts not into saccharic acid but into gluconic acid. That is gluconic acid. So we get gluconic acid and not saccharic acid. What is saccharic acid? This is also COOH in saccharic acid, and this is also COOH. Let me just write it down. We get saccharic acid in the case of, let me just make it 4. That is nothing but the saccharic acid, and we need to take up a strong oxidizing agent here in this case, that should be HNO3 in order to actually get the saccharic acid. But otherwise for mild oxidizing agent we get gluconic acid. So that is gluconic acid. So I hope everybody has recalled the reaction. Now let us just tick up the option. This is also incorrect now, because it says that we get saccharic acid as the product for bromine water reaction. So that is not true. I hope everybody has got the answers here. B is correct and C is correct. So that is what we need to do here. Let's now move on to the next question. Again, I'll be having a multiple choice question. So what it says, again, such complicated structures but yet having a very simple answer. The correct statements about the following sugars X and Y are. Now you need to check, these two are the sugars which are given, X and Y. So if you observe over here, and can you observe one more thing in this very sugar, there is no reducing part present. And also what? If you see over here, there is a reducing part present. In fact, yes, this very part is reducing here. That means this is a reducing sugar and this is a non-reducing. So one thing we have got here. Also, if you observe the type of linkages, what are the type of linkages here? So if you see, that is the beta linkage and that is the alpha linkage that we have got. So now let's move on to the options. We have actually deduced certain data out of these two options. So now X is a reducing sugar, Y is not. This is not true. X is non-reducing while Y is reducing. That is true, we have found out. The glycosidic linkage or glucosidic linkage in X and Y are alpha and beta respectively. That is what it is. So let us just observe. Here it was alpha, here it is beta linkage. So I hope everybody has got the answer here. This is also right. The glucosidic linkages in X and Y are beta and alpha respectively. That is not true. So I hope everybody has got the right answer. B and C are the answers for this question. It was pretty simple. Now here comes the big question. What big question? Having a comprehension passage, you need to read it out because there may be certain answers which are hidden in this passage only. So alpha amino acids, again it's talking about alpha amino acids are the building blocks, we all know. About 20 amino acids have been isolated from hydrolysis. So every time we perform hydrolysis in order to isolate different amino acids, we know that. Now all these amino acids except glycine are chiral and have L configuration, we know that. 20 amino acids isolated by hydrolysis. So just mark out the important points over here. 10 amino acids, valine, and these are all given, which the body cannot synthesize, are called essential amino acids, and we have got for the non-essential, which are actually synthesized by the body. Now all the alpha amino acid exist as zwitterions. We all know that what zwitterion is, NH3 positive and COO negative. That should be a particular kind of scenario in the amino acid. Now above the isoelectric point, now this very thing is important, above isoelectric alpha amino acid exists as anion. That means below isoelectric point it will be existing as what? A cation. Now 2, 3 or many alpha amino acids form ditri, such polypeptides. Each polypeptide has a free amino acid at one end, that is the N terminal, and the other has got the C terminal, and they have mentioned different reagents for the C terminal. Yes, there is Sanger's reagent that is used for the determination of N terminal, and C terminal is used as hydrogenolysis. So that is what they have mentioned. I hope everybody has got the comprehension over it. It's pretty easy. Now let's move on to the questions. So are we able to solve these questions or not? The acid showing salt-like character. What is a salt-like character? Salt-like character is definitely present in the amino acid. How? In order to formation of zwitterion. So that is known as the salt-like formation, having a positive as well as a negative ion within the same molecule. So where is our option? Acetic acid, benzoic, formic, all of these are acids. But if you see, this is alpha amino acid. Only the amino acids are having a salt-like character. I hope everybody has got the answer over here. Let's just move on to the next question. Now the next question says an alpha amino acid below its isoelectric point exists as, so we have discussed this already. So in the question it has been mentioned in the passage that the alpha amino acids above isoelectric point it exists as anion. So below it will be existing as what? A cation. That means where is the cation? Here is the cation, but if you see there is an anion as well. So I need not go for this option. Therefore, this is the option, only option having a cation in it, because here it will be behaving as acid, behave as acid, pH gets reduced. So that is the actual logic behind why this is behaving as a cation below the isoelectric point. So I think everybody is able to correlate it with the main concept. Now let's move on to, yes, which of the following reagents is used to determine the C terminal? So they have told in the passage itself that N terminal is used for, this very reagent is used, that is Sanger's reagent. I need not go for that because it is for the N terminal. Now they also told us that C terminal, for the C terminal we use hydrazinolysis. Hydrazinolysis. What is hydrazinolysis? Using the reagent hydrazine. And now what is hydrazine? NH2, NH2. So that is what we need to have. That means hydrazine we need to have. That is another kind of an information that would be important to you. We are not going for 2,4-dinitrophenyl hydrazine. This is not the reagent as well as this. So I hope everybody has got the answer. Let's move on to the next question, the last question of the passage. I have given this kind of a structure having positive, these are the cations which are present. Also this is an amino acid arranged in the order of the decreasing strength. So this is Z, this is X, this is Y. So a good acid will be what? Will be the one which is able to donate the H positive or able to fetch the electrons easily. So that is a good acid. So here if you see, due to the resonance, that is how the resonance will be taking place. This H positive can go off very easily, in fact more than these cations present. That means X should be at the highest, X should be at the highest. Now if I move towards this very cation, so for this cation, this group, carboxylic group is serving as withdrawing group. So this is a withdrawing group, also there will be involvement of resonance. That is why it is able to abstract the electrons very easily, or I can say it is able to donate this H positive very easily in order to obtain what? NH2 group. That means after this it would be Z, and finally Y. This is the least because this is far away from this withdrawing group. So I hope everybody has got it. You need to apply the general organic chemistry concepts over here. So now we get the answer, it is A. I hope everybody has got the same answer. Let's now take up the second last question what we have. Assertion reason type question. Again we know all the kinds of the rules which are in assertion reason type. Statement 1 is true, statement 2 is true, but there is not a correct explanation by the statement 2, or there may be a correct explanation. Statement 1 is true, statement 2 is completely false, statement 1 is false and the 2 is true. So that is how we need to select the options. Let's just now go on to the question. Statement 1, what does it say? Glucose gives a reddish brown PPT with Fehling solution. It gives a reddish brown precipitate with Fehling solution. Yes, because it is a reducing sugar. So how does the reaction takes place? With Fehling solution, Cu plus 2 ions, OH negative, and what do we get? We get COO negative, that is sort of a gluconic acid that we get. And what else? We get Cu2O as a red precipitate. So you need to know a proper reaction over here, reddish brown precipitate. So first statement is definitely true. Statement 2, reaction of glucose with Fehling solution gives CuO and gluconic acid. So we are definitely getting the gluconic acid here, but we are not getting CuO. Look carefully. We are getting red PPT of Cu2O and not CuO. So that means this makes this statement not an incorrect explanation, but it is completely false. This statement in itself is incorrect. That means we are choosing what kind of an option? So we will be choosing option having statement 1 is true, statement 2 needs to be false. That means C is the answer over here. I hope everybody has followed up. It's a pretty simple question. So the reducing properties of sugars, the questions of these type are frequently repeated in the exam. Let's move on to the very last question. It's the integer type and it looks pretty difficult. Let us just find out. The total number of distinct naturally occurring amino acids obtained by the complete acetic hydrolysis of the peptide. So this is the peptide which is shown, and I need to perform complete acid hydrolysis. That means I need to break down into the amino acids, the basic amino acids, the monomers. So how will I break down? So if you know each and every amino acid, like this, so if you observe over here, I have connected two amino acids. One is this, the other one is this. So these are connected via what? Via a peptide bond. So that is a peptide linkage, CONH. So I need to separate the two amino acids if I see this peptide linkage. So that is what I need to find out. So let us just break it down. It's a very simple question. So if you see a peptide linkage, NHO, that is a peptide linkage. So I'll breaking it down. That means these are the two amino acids that would have been attached. Now again CONH or maybe N. So it is again one amino acid. I'm breaking it down. Now what do I need? Okay. O, N. Again O and N. That is another one. Again what? Another one. Again what? Another one. ON. Another one. ON. Another one. And ON. Another one. So that is how we are going to find out the total number of amino acids which would have been once joined in order to form this entire peptide. So let us just count. What do we have? We have this one as 1, this as 2, now this as 3, now this as 4, I've got 5, I've got 6, I have got 7, this is entire is 7, and I've got 8. That means finally I've got how many? I've got total of 8 amino acids. So we have got the answer to this question, the integer as 8. So that is our answer, 8 alpha amino acids have been attached. So I hope everybody has got the answer and the technique of breaking it down. You just need to see the peptide linkage and just break that down. So I hope everybody has followed up all the questions properly. You have understood all the concept that I have explained. Even if not, just try to practice, just try to go through once again. You will be getting it soon. So I'll be back with a next questionnaire round in the next session, or maybe some kind of sessions for another chapter. So till then, have a good day.